Okay, folks, this video is about the calculation of pOH value for strong acid and strong base. And as we discussed in our lecture, it's relatively easier to calculate those pOH value for strong acid and base, because for strong acid and strong base, they will give you 100% dissociation in water. All right, so based on this, okay, the concentration of the strong acid and strong base themselves would be the concentration of the hydronium or hydroxide. So let's take a look at these two examples. And here I give you this concept map. I just want to guide you through the procedures when we calculate those OH concentration and hydronium concentration. Let's say first one. If you have 0.00250 mole per liter of nitric acid, then what's the pH value? What is the pOH value? And then what is the concentration for hydronium and hydroxide? Remember, nitric acid is a strong acid. That means when you dissolve nitric acid in water, it gives you 100% dissociation to generate hydronium and nitrate. Okay, sorry, this is a plus sign. And nitrate. Because this is a 100% dissociation, the concentration of nitric acid equals to the concentration of hydronium. Therefore, you don't have to do any calculations to get the concentration of hydronium. So, nitric acid concentration equals to the concentration of hydronium. All right, so that is 0.00250 mole per liter. Now, if you take the negative logarithm of hydronium concentration, you got the pH value. Okay, so very simple calculation. And my calculation gives me 2.60. And when you got the pH value, the pOH value would be easier because we have this relationship. So pOH value equals to 14 minus 2.60, and it's 11.40. Okay, so the last part would be the calculation of hydroxide. And because take a look at this equation, because the product of hydronium concentration and OH concentration equals to 10 to the negative 14. So if you know the concentration of hydronium, then you should be able to calculate the hydroxide. So here for this problem, that would be hydroxide concentration equals to 10 to the negative 14 over the hydronium concentration right here, 0.00250 mole per liter. And my calculation is 4.00 times 10 to the negative 12 mole per liter. So this is how we calculate the pH value for strong acid. And if you have a strong base, you are going to do the similar thing. Let's take a look at this second example. Calculate the pH, the hydronium pH value, hydroxide, and pOH value for 0.360 mole per liter of lithium hydroxide solution. Lithium hydroxide is a very strong base. Therefore, 100% dissociation in water, give you lithium 1 plus and hydroxide. So the concentration of lithium hydroxide equals to the hydroxide concentration itself. And that is 0.360 mole per liter. All right, now here's the thing. You have the concentration of hydroxide. If you take the negative logarithm of hydronium concentration, that gives you the pOH value. Okay, so be careful when you take the negative logarithm of those hydronium concentration and hydroxide concentration. And think about what they will give you. All right, so here negative logarithm of 0.360 mole per liter would be the pOH value, and that is 0.44. So this is a pOH value. Now, as we did in the previous example, you just use a 14 minus 0.44, and then you got your pH value, which is 13.56, very basic solution. Okay, so last item is the concentration of hydronium. Again, we used 10 to the negative 14 divided by the hydroxide concentration right here, 0.36 mole per liter, and you get 2.78 times 10 to the negative 14 mole per liter. Okay, so this is how we deal with the strong acid, strong base. Remember, the key information is 100% dissociation for strong acid and strong base. If you have any questions, please let me know.